So hey, hi everyone. Myself Swarnabha or Swarna, and I'm the solution engineers at Taiko. And today I'm gonna present about base rollups, basically what we are building in Taiko and how we are unique, and eventually how it's the only real extension of Ethereum. And yeah, I'm based out of India, and I would love to take your questions or anything suggestions after this talk. So I think yeah, let's get started. So, roll-ups in idea and in production has been there over years. According to me, like as far as I know, there has been, I guess, over around 150 roll-ups, and yeah, there are a lot being produced as well. There is going to be a lot more as well. So we all know roll-up is a basically idea to scale Ethereum, right? It was proposed to scale the L1. So yeah, as we see, this is from L2 beat, like the total value locked is around, it's now more, but yeah, so it's around like 37 or 38 billion, and it's around like 300 TPS from rollup. So it's like it's one of the most prominent way to scale Ethereum. So yeah. So rollup centric roadmap has basically given us an endless source of experimentation. There has been a lot of things going up since the time of like since the rollups were in production. For example, alt VMs or alternate VMs, like projects like Fuel or Fluent are building on this, like to scale the rollups now using alt VMs. There are ZK VMs as well, like Aztec, Starknet, and others like Succinct. So they are building on that end. And then there are ZK EVMs as well, like very famous like L2s, like Scroll, ZK Sync, Linear recently. So yeah, and obviously parallel EVMs like Mega ETH, what recently gave the idea to do the things parallelly. So what is majorly the problem over all of this? And I will discuss how we will going to work on this and how we are working. The first thing is the lack of interoperability. So at the end, a particular rollup is siloed at towards the top, right? So the two rollups, or let's say more than two rollups, are not interoperable. Like you cannot access the things or assets from one rollup to another rollup. So that's one of the major problem, which is very concerning, like lack of interoperability. Liquidity fragmentation, like you cannot access the liquidity from on one rollup to another until you need to bridge, and then again you need to bridge, and it actually takes a lot of like time, and let's say it takes some asset as well. So the liquidity also is also fragmented, and the interoperability is already there. And there is obviously philosophical disconnection, like the rollups which are mostly are centralized, and this was never the idea of a rollup. It was always the end game was to be decentralized. So yeah, based on the idea which was proposed, it's like disconnected. So there are few solutions, and there will be more solutions as well. So one of it is shared sequencer, other is real time proving, and the third one what we are building is base rollup. So I will discuss one by one, and yeah. So what actually is shared sequencer? So it's basically a layer, that connects the sequencing rights to the participating rollup into a single sequencer network. So in this you opt in basically, and rollup can take advantage of decentralization, and also there is fast pre-confirmation as well. So by design, we all know there is a 12-second block time from L1 to L2. So this is actually like solved when you are using shared sequencer. So this is basically a sequencer marketplace, in like rollups can sell their block space and obviously proposing rights and to hire bidders slot by slot. So this is like basically a demonstration how things work. So how it works is like there are, let's say, different rollups what we are talking about. So how it happens is like the validators take, and then from all the rollups it goes to a shared sequencer used by all the rollups given at a time. So this is good, but what's actually the problem, or what actually is the con of it? So this is kind of a pure business to business model. Basically, you are selling your sequencing rights to whoever is bidding the highest. So like for example, there are few like in a marketplace there are more than various sequencers, right? So whoever bids the highest for the sequencing and obviously the proposing rights, they get it, right? So this is kind of a business model, and it also introduces new security assumptions. So this assumes basically that like when you are giving the rights, it's to the right authority, so there is no check in between. And yeah, and there is always a network effect which is difficult to maintain, and at the end it's just adding another layer. So yeah, it eventually increases the cost even though it gives a better UX. The other solution is real time proving. So for example, there are like I've taken three roll-ups. So let's say they have particular slot duration, right? So at a particular time, two roll-ups are proving basically to proving their blocks to L1, but not the third one. Again, two roll-ups again. Let's say B and C is proving, but not A. But there will be definitely a time when all the three are proving together. So that's what we find, and then we do it like with real time proving. So you can like real time proving can be done using obviously hardwares. Like there are a lot of hardwares. So basically, let's say there is two rollups as I showed. Like they are proving together. So at that time, you can do your transfer, or let's say access the liquidity together. So when so you there is obviously ways to find uh, the the time when they are proving together. So yeah, in like any case, there will obviously be a time when all the parts will be proving together, like all the roll-ups. And yeah, there are hardware, but it obviously it increases the cost, right? So it there are hardwares basically to check when like the proving happens between the roll-ups you choose. So yeah. So now, basically, what we are building is like base rollup. So like here we are using Ethereum as a like natural shared sequencer. So by definition of like base rollup, so what it means is the sequencing is driven by the base L1. Like you are not using any centralized sequencer. In fact, the sequencer here is Ethereum L1 itself. So as you know, like there are four layers, right, in a rollup: settlement, data availability, consensus, and execution. So what happens is Ethereum. The L2, which is based L2, post its proof to Ethereum. So like settlement layer is Ethereum as well. Data availability layer is obviously Ethereum. So Ethereum is used as a DA layer, and then like it does not require any particular consensus layer. And yeah, in rollup transactions are happening off chain. So yeah, the settlement is so when the layers are removed, it eventually removes the cost. So yeah, it's more cheaper. So how it happens is, let's say this is a diagram of how base rollup works. So like let's say we have like L2 based L2 rollup, and this is L1, which is Ethereum. So when you post your transactions on L2, so it goes to mempool where all the transactions are there, and which is packed. So what happened is L2 transactions are there in the L2 mempool, and then they are bundled, and the L2 block builders, which makes the L2 blocks, send it to L2 L1 searcher. So basically here, what happens is by definition, L2 builders, which takes the transaction after bundling, is the L1 searcher itself. So L1 searchers acts like the L2 builder. So they take the transaction and then they bundle it in L1, and then yeah, it's proposed in L1 block. So this whole by definition takes 12 seconds, which is one of the, I will discuss later on. It takes like, it's one of the major UX problem. So yeah, this is by definition base rollup. So So yeah, the pros is you don't need any extra engineering effort. Like you are actually using Ethereum like sequencing. So the sequencing is driven by L1 like which is Ethereum. So it inherits the full security and liveness of Ethereum as you are posting data, you are proving also data to Ethereum. So it's inheriting like by definition and by philosophy the full security and liveness of Ethereum. So by definition, what has been proposed by Justin Drake for like MEV is like most of the MEV flows to the L1 from L2 in base rollup to incentivize the if you see L1 searchers to incent and take the to make the propose the blocks. Most of the MEV flows to like L1 searchers to L1. So by base rollups are currently is the best way to incentivize Ethereum. So yeah, and obviously it's decentralized because we are not using any centralized sequencer for sequencing. So it's driven all by L1 in a decentralized manner. And this block proposing is permissionless. Like anyone can be a proposer and prover. Like any one of you can just run a Taiko node, for example, and can be a proposer and a prover, and you can actually earn incentive as well. So yeah, cons obviously there are currently few cons, and that's what the major concern for us is when we are the only production level based rollup right now. So we are working on removing the cons. So bad UX obviously, it the block time, which is by definition is 12 seconds. So for example, like use cases like DeFi, or let's say which uses a lot of transactions, it actually is sometimes 12 seconds is a lot, because when you send a transaction to go into L1 block, it actually takes 12 seconds. So which is considered a lot in very various applications, which is being worked on. That's what I will explain. So limited revenue, obviously, as I said, most of the revenue flows to the MEV flows to L1. The revenue source is less. Yeah, there can be permissionless attacks if implemented in that way. So yeah, so how we deal it, we are dealing it with so we are currently working on based pre-confirmation. So the devnet, so what pre-confirmation is, like it uses the L1 proposer to provide a pre-conf or a pre-confirmation to L2 user. So before even the transaction is confirmed, it gives a pre-confirmation, because that's it using L1 proposer now. So yeah, and pre-cons, this is opt-in for all the users. Like you just need to opt in through the contract. And are currently working with Nethermind. If you have seen, Nethermind recently launched their new chain, which is the Surge. It is built with Taiko stack. So that is our pre-con solution. So currently our devnet is live for pre-con. So testnet will be in few months. Few like next month, yeah, the mainnet will be in few months. So with pre-cons, you are actually removing the UX of 12 seconds, because it actually gives a pre-confirmation to L2 user. So the profitability, the like okay, yeah. So the I will just wrap it up quickly. So before, what happened is like base fee used to go to the rollup operator, the priority fee which a user adds to get your transaction included faster, and the MEV can order as it wishes, right? It's permissionless. So now what is happening is the proposer will be able to capture a large percentage. Actually, it's 75%. The priority fee and the MEV remains the same. What it will be added is a pre-con fee, so user can pay a pre-confirmation tip to the proposer to get their transactions included quickly. So yeah, this is something like the security we have using multi-proofs, using a combination of RISC-0 and succinct labs SP1. So it will give like all the blocks which are being proposed will be secured by multi-proofs. So yeah, this is something like we are on the tier 3, which is using SGX plus ZK EVM. Uh, so so yeah, the summary is basically we all are tired of centralization of rollups, and Taiko is one of the first solution to bring decentralization in rollup. which is doing sequencing in a decentralized manner. So yeah, thank you.